we've got a suitcase here, and this is a situation where it's pivoting about this point here. Okay, so this is one of these suitcases that you take perhaps on holiday with you, go to the airport with, whatever, and it's on wheels. So you're rolling it along at an angle, and you can see that the person pulling this this suitcase is applying a force of 50 newtons upwards to keep it from falling over, and there is obviously the weight acting downwards, and in its current situation it's just stationary. Okay, so the suitcase is stationary. It's being held stationary by this force against the weight which is trying to tip it over, obviously. Okay, so it's stationary. So it's basically a situation where we know that the forces are in equilibrium, but also we know that the sum of the clockwise moments must be equal to the sum of the anti-clockwise moment, okay, because it's in equilibrium. All right, so this is a moments problem. So this is our pivot point, and you will remember that a moment is defined as the force multiplied by the perpendicular distance from the pivot point. Okay, so the force multiplied by the perpendicular distance from the pivot point. And it seems in this question, because you've got an angle here between the force that's applied and the object, which is on an angle. You can see the object's obviously on a diagonal. You think perhaps you have to resolve this force into components that are perpendicular to the object and horizontal to the object, or perpendicular to the object, sorry, and parallel to the object. But you don't actually have to do that, because the moment is defined as the force multiplied by the perpendicular distance. We know the perpendicular distance from the pivot point to this force. It's 46 centimeters. We know the perpendicular distance from the pivot to this weight force. So we don't need to do any resolving forces here. It's a nice simple problem. So this force is producing a clockwise moment. This one's producing an anti-clockwise moment. And the whole point in this question is to work out what this weight is, what the weight of the suitcase is, and then work out the mass of the suitcase. So the clockwise moment is 50, so that's the force, multiplied by the distance. So force times distance. So we know that moment is equal to the force multiplied by the distance. But remember, this is the perpendicular distance from the pivot point. So force times distance, 50 times, and we're 46 centimeters from the pivot point. So I'm going to turn that into meters just to keep it in a standard unit. And that's got to be equal to the anti-clockwise moment. And the anti-clockwise moment is produced by this weight here. That's turning the suitcase anti-clockwise. So it's the weight multiplied by the distance. Now, be careful here. The distance is not 32 centimeters. It's 46 centimeters. Take away 32, which gives us this distance here. Okay. So that distance there is 46, take away 32. Okay. Which obviously is going to give you 14 centimeters, and therefore 0.14 meters. Okay, so all we got to do now is rearrange that. So we get W equals 50 times 0.46 divided by 0.14, and that's going to give us an answer of 164 newtons. Sorry for that move in there. And then to work out the mass, which is the final part of this question, we know that the mass is equal to the weight divided by gravity. So it's 164 divided by 9.81. Okay, and if you take your calculator and put that in, you're going to get 164 divided by 9.81, which gives you 16.7 kilograms. Okay, so 16.7 kilograms. And if you rounded that to two significant figures, it's going to be 17 kilograms. Okay, and it would probably make sense to round it to two significant figures, since that's two sig fig, that's two. There you go. All right, and we could even round this one to two sig fig here and call that 160 newtons. All right, so the mark scheme actually says that you can have this is a 3-mark question, and you would get the full 3 marks if you used 164 and worked this out as 16.7, or if you quoted it as 17 kilograms, that would all be fine. If you rounded this to 160 newtons, that's then going to mean that this would change. This would become 160 over 9.81, which would give you 16.3 kilograms. And that still would get you the full 3 marks. And again, if you rounded that to 2 significant figures and quoted it as 16 kilograms, it would still get you the full 3 marks. So it just shows you that there are variations in these A-level questions that will get you full marks, depending on how you decide to follow through with significant figures. Okay, but definitely 2 or 3 significant figures here for your answer.